What we're going to work on now is section 5.1b, and we're going to talk about turning points, increasing, decreasing, and using differences to determine degree for polynomial functions. So to start out with, let's talk about what the degree of a polynomial function tells us. Well, the degree for a polynomial function affects the shape of its graph. It determines the maximum number of turning points, which are max or min points, which if you remember from parabolas, those max and min points look like vertices. So for a leading term of ax to the n, a is the coefficient and n is the degree. So for example, 6x to the fifth. So 6 would be the a, 5 would be the n. Then what that tells us is the maximum number of turning points is going to be equal to n minus 1. So in my example of 6x to the fifth, if that was my leading term, then this would have at most 4 turning points or turns. The degree also determines the end behavior of the function. So if you remember parabolas, like both ends go up or both ends go down. So when we have a leading term of ax to the n, where a is the leading coefficient and n is the degree, then we're going to fill out a little chart over here. We want to look at the leading coefficient and decide if it is positive or negative. So if a is positive or if a is negative, that's the leading coefficient. Then we want to look at the degree, and we want to know if n is even or n is odd. If n is even, then the ends of our polynomial function will behave like a parabola. So if you think about y equals x squared, where the leading coefficient is positive and the degree is even, then both ends went up. Now with a polynomial function, anything can happen in the middle, so we could do any kind of crazy business in the middle, but what's going to happen is that the left end and the right end will be up, so the end behavior will be up, up. Now if the leading coefficient is negative, like negative 3x squared, that negative out in front does a reflection across the x-axis, which makes our parabola or polynomial function flip upside down. So in that case, our ends would both be down, so that will be down and down. Now, if you think about y equals x cubed, where our degree is odd, that we studied in section 5.9, then if the degree is odd and the leading coefficient is positive, then our ends will behave like y equals x cubed, although a polynomial function may have more turns in the middle than a cubic function. But what our ends are doing is the left end is down and the right end is up. Then if we have a leading coefficient that is negative, then that flips our function upside down across the x-axis. So our ends would go up on the left and down on the right. So in this example, when I said 6x to the fifth, my leading coefficient was positive and my degree was odd because it was 5. So the ends for my example would be down and then up. Let's talk about where a function is increasing and decreasing. So a function is increasing when it is going uphill from left to right. A function is decreasing when it is going downhill from left to right. So if you look at this little picture here, we would be increasing until we get to here, and then decreasing, and then increasing, decreasing, increasing. So we're going to look at that a little bit more closely here in just a moment. I want to sketch a little graph here. Now your graph doesn't need to be exactly like mine, but it should be somewhat similar so that we can talk about where these graphs are increasing and decreasing together. Just if you make it look generally that shape. Now, the way that we describe where a graph is increasing and decreasing is by using the x values. So we use the x values of the turning points to create intervals stating where the function is increasing and decreasing. So the turning points are the things that look like maximums and minimums. So we have right here, we have a turning point that is a minimum. And right here, we have a turning point that is a maximum. Now, I'm just going to make up ordered pairs for these. So don't worry about if everything's drawn to scale. I'm just going to say that this minimum is at -5, -3, and I'll say this maximum is at 4, 10. So what these turning points or maxes and mins do is they're going to break up the x axis into different intervals. So remember that this arrow on the left end represents -infinity. This arrow on the right end represents infinity. And then we're going to imagine that this maximum breaks up the interval at 4, and this minimum breaks up the x-axis at -5. So when we describe where a function is increasing and decreasing, we're always going to go from left to right across the graph. And so we'll start always at the left end here. And so if you look at this graph and you imagine if you're a little ant crawling across this graph, you want to kind of ask yourself, if I was on a roller coaster, would I be going downhill or uphill? So if I start on this arrow, you can see that riding along the roller coaster, I am going downhill, 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 until I get to this minimum right here. And then I start going uphill, uphill, uphill. And then I get to this tall point, and then I'm going downhill, downhill, downhill again. So we can think of these in terms of increasing and decreasing. So I'm going to label this part decreasing. And then I have a section where I am increasing all the way up to here. And then we are decreasing again. So when we want to list our intervals where the function is decreasing and increasing, we're going to use x values. So my breaking points on my x values are going to be -infinity, -5, 4, and infinity. So all of those numbers are going to be used or thought about when I list my increasing and decreasing. So when I start out at -infinity, remember I was going downhill until I got to -5. So what I will do is I will color that part pink because that's the color I was using for decreasing. And then what happened at -5 is I started increasing, increasing, increasing all the way till I get to 4. So that part of my x-axis is going to be green to represent increasing. And then it was decreasing again, going downhill. So that part will again be pink. So since I have 2 pink sections and 1 green section, I'm going to have 2 different inequalities for my decreasing. This function is decreasing for all of the x values that are smaller than -5. So my one inequality will be when x is less than -5. Now that'll always be a less than. It won't ever be less than or equal to, because what's happening at -5 is the function is turning around. So it's not decreasing or increasing. It's decreasing, turning around, increasing, turning around, decreasing. So it's decreasing when x is less than -5, and it's also decreasing again for all of these x values, which would be all the x values that are bigger than 4. So x is greater than 4. This graph is increasing for all the x values in between -5 and 4. So that's going to be a compound inequality. So it's going to be all the x values that are trapped between -5 and 4. And when we write that compound inequality, the arrows always are the less than symbol. So we go -5 is less than x and x is less than 4. And that's how we'll show that. Now we can also use our graphing calculator to find ordered pairs for maxes and mins. So we're going to combine what we just did with this graph with the idea of graphing an equation on our calculator and using the calculator to identify maxes and mins. So we will get this graphed. Here's just a reminder about how you find maxes and mins. We're going to be using the second calc menu, and then either number 3 to find a minimum or number 4 to find a maximum. Then we put our spider on the left, spider on the right, spider on the point, and that will give us our maxes and mins. So we'll go to y equals, and we'll type in y equals 4x to the 4th plus 6x cubed minus x. Now when I look at that in the standard window, I don't get a very good picture. So what I'm looking to find is where the maxes and mins are. So I'd like to zoom in on this area. So one way to do that is to do zoom box. And then it gives me a little plus sign that acts like the corner of my window. So I put my plus sign where I want it. I hit enter, and then I kind of open that box up by using my arrow keys until I have everything inside the box that I want to see, and then I hit enter again. And that's going to zoom in to really let me see where those maxes and mins are. Now there's several things that we want to do in looking at this graph. One of the things is talk about end behavior. The end behavior, remember, goes based on the leading term. So our leading term was 4x to the 4th. So when we look at that leading term, a is the leading coefficient, n is the degree. And so what we need to know is if the leading coefficient is positive or negative, which it's positive, and if n is even or odd, which it is even. So then for the time being, you can refer to your chart up here. If our leading coefficient is positive and our degree is even, our ends go up and up, which you can see from the graph. The left end is going up, the right end is going up. So our end behavior is up, up. And then for the turning points, that's going to be where we find our maxes and mins. So I can tell by looking at this picture here that I have a maximum right here, and I have 2 minimums. So when I go to list my turning points, I'm going to list a maximum and 2 minimums. And I will give those as ordered pairs when I get the calculator working here in a second. And then we're going to use the maxes and mins to figure out where the function is increasing and decreasing. So I'm going to want to figure out where these x values are, because remember, that's what's going to split up my intervals. So I'm just going to draw little dashed lines through here, and kind of, I will label what my x's are as I get to them by finding my maxes and mins. Okay, so here we go. Let's just kind of go left to right. So we'll find this minimum first. So we're going to do second calc, and then we're finding a minimum. So we'll want to choose number 3. And then it's going to ask me for left bound, right bound, guess. So this is the point I'm looking for. So I want to move that spider left, 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 left until I go past the point and then hit enter. And then it changes to right bound. So I want to move the spider to the right of what I'm looking for. Hit enter. And then when it says guess, I want to go to the spot I'm looking for. Hit enter again. So that minimum is negative 1.07, negative 1.04. We'll just round to the nearest hundredth. So negative 1.07, negative 1.04. And then I'm going to label this x value negative 1.07. Okay, and then I'll just keep going like that. This one is a maximum right here, that maximum. So second calc, find a maximum, which is 4. And I need to be on the left-hand side of there, which I am now. Hit enter, and then go to the right-hand side of there. Hit enter, and then go to there and hit enter. So that maximum would be at negative 0.27 and then 0.17. So I'll label that x value negative 0.27. And then my next minimum right here, second calc, find a minimum. Need to be on the left of it, so go to the left of it, hit enter. Go to the right of it, hit enter. Go to it, hit enter. And that is 0.22, negative 0.15. So x equals 0.22. Now let's look at what this function is doing, if it's increasing or decreasing as I move left to right. So remember that we want to start at the arrow. So if I start at the arrow and I move along the graph from left to right, I start out by going downhill. And then here I turn around and I go uphill, and then I go downhill, and then I go uphill. So on my intervals, I start out going downhill, and then just for a little tiny bit, I go uphill. And then for an even tinier bit, I go downhill again and then uphill again. I'm not sure if you can see where I've got that itty bitty section of pink there. So that is my decreasing section, my pink here and the itty bitty pink there. That itty bitty pink there was in between x equals negative 0.27 and x equals 0.22. So maybe I'll draw my colors down at the bottom as well so you can see them a little bit better. So my sections of decreasing are all the x values that are smaller than negative 1.07. So decreasing, x is less than negative 1.07. And then also again, in between here. So when it's in between two numbers, we put the x in the middle, we put two less than symbols, and then we put our numbers. So the left side would be negative 0.27 and the right side would be 0.22. And then my graph is increasing in two sections. Right here, it's increasing trapped between these two values. So I'll have x trapped between two numbers with the less than symbols. It's trapped between negative 1.07 on the left and negative 0.27 on the right. And then it would be also all the x values that are larger than 0.22. So x is greater than 0.22. We'll have a few more opportunities to do this here on the back side of this page. Okay, so let's practice. Negative x squared plus 2x. We can look at that a couple of ways. We can look at the sign of a being negative and the degree of n is even. We can also look at the picture And we can see that both of these ends are down. So our end behavior would be down, down. I can see on here that I have one turning point, and that turning point is a maximum right there. So I'm going to have a maximum, and I'll get that on my graphing calculator in a moment. And then I can also see that wherever this maximum is, whenever I get it figured out, that my graph starts out, if I start on the left-hand arrow, I'm going uphill. So my graph is increasing, and then it turns around at that point, and then it's decreasing. So it's going uphill, increasing, then going downhill, decreasing. So let's type in that equation and find that maximum. We go back to y equals, clear out what we had, and it is negative x squared plus 2x. So I need negative sign x squared plus 2x. And we'll just go back to the standard window. So zoom 6. And then I'm looking for that maximum. So second calc, find number 4, the maximum. So here's where the maximum is. So I need to go to the left of it, enter, go to the right of it, enter, and then on it as much as I can, enter. Now, if we're rounding to the nearest hundredth, then I would look to the right, and that is a 9, so I would bump it up. So that maximum is actually going to round out to be an x value of 1, and the y value already says 1. So 1, 1 would be our maximum. Calculators sometimes don't do a super great job of rounding. So here's my x value of 1. Remember, we use the x values for our value, our increasing and decreasing. So what we're going to do is we are going to start out increasing. It's increasing for all the x values that are smaller than 1. So increasing when x is smaller than 1. And then it's decreasing for all the x values that are greater than 1. So it's decreasing when x is greater than 1. Here's our parent function, y equals x cubed. We can tell its end behavior. The leading coefficient is positive. The degree is odd. I can look at the graph and see that the ends are down and then up. Let's see about increasing and decreasing and turning points. If I were to get on my graph at the left-hand arrow and ride along it, I can see that I'm going uphill, 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 uphill. So since my graph is going uphill the entire time, it is increasing all the time, which means it's increasing for all real numbers. Another way to write that is to trap x in between two numbers. Well, what's it trapped in between? It's trapped in between infinity on this end and negative infinity on this end and positive infinity on this end. So we would have x is greater than negative infinity and less than infinity. And that's how we would show that. As far as turning points, there are no turning points. And where is this graph decreasing? It's never decreasing. So it's decreasing nowhere. This is another cubic function, but this one is more complicated than that parent function. So let's go ahead and type that in. Negative x cubed plus 2x. And then look at the graph. And again, we can zoom into this little section by doing Z box if you would like to be able to see a little bit closer detail. It sometimes makes it easier to find your maxes and mins. The end behavior for this function, we can see that it's got a negative leading coefficient and the degree is odd. So if you look back at your chart, if A is negative, and the degree is odd, our ends go up, down. And we can tell that by looking at the graph. The left end is up and the right end is down. So let's find our turning points. Because remember, turning points are going to split our x-axis into different sections that we'll be able to use for telling where it's increasing and decreasing. So as far as turning points, I have a minimum here and a maximum here. So I'm going to have two. I'll have a minimum and a maximum. So second calc, let's find that minimum, which is right here. So I need to go to the left of it and hit enter. And then to the right of it and hit enter. And then on it and hit enter. So that minimum is at negative 0.82 and negative 1.09. So this x value is negative 0.82. And then for the maximum, second calc, find the maximum. And we got to do left bound, right bound guess again. So left bound, enter, right bound, enter, guess, enter. Oh, that is at 0.82, positive 1.09. That's very symmetrical. So this x value is 0.82. So in terms of what's our graph doing, we start out going downhill, so we are decreasing. And then we're going uphill, so we are increasing. And then we are going downhill again, so decreasing. So our decreasing, we have two intervals. All the x values smaller than negative 0.82. So x smaller than negative 0.82. And then again, all of the x values that are bigger than positive 0.82. So x is greater than 0.82. And then where's our function increasing? It's trapped in between two numbers. So we do the x trapped between two numbers. The small number is negative 0.82. The big number is positive 0.82. Okay, the last thing that we're going to look at is using differences to determine degree. So differences mean that we are going to be subtracting. So when we look at using differences, differences means subtraction. And the word constant is going to mean the same. So if your first differences are constant, or when you subtract the first time they are the same, then your function is going to be linear. If your second differences are constant, the function will be quadratic. If the third differences are constant, it will be cubic. And if the fourth differences are constant, it will be quartic. By the way, if the fifth differences are constant, the function will be quintic. And we could keep on going, but I don't think we'll have to go that far in what we're going to do for this course. So let's look at how to make this work. So here's our table on the right. What we're looking for is the differences between the y values. So kind of the easiest way to do this is to list out the y values. So I'm just going to list out my y values from this table in order. So my x values always have a difference of 1 in between them. So my y values go 23, negative 16, negative 15, negative 10, negative 13, negative 12, and 29. And I'm going to start out looking at the first differences. So what I'm going to do is I'm going to go between 23 and negative 16. And the problem I'm going to be doing is 23 minus negative 16? So if I get in my calculator and I do 23 minus negative 16, that gives me 39. And then I go to my next pair here, and I'm going to do negative 16 minus negative 15. Negative 16 minus negative 15, which gives me negative 1. And then I do the next pair, negative 15 minus negative 10, which is negative 5. And then negative 10 minus negative 13, which is 3. Negative 13 minus negative 12, which will be negative 13 plus 12. So that should be negative 1. And then negative 12 minus 29, which is negative 41. Now, our first differences are not all the same, so it is not linear. So then we move on to second differences. And we're going to do exactly what we just did, except for we're using these numbers now. So we're going to do 39 minus negative 1, which makes 39 minus negative 1 makes 39 plus 1, so that is 40. And then negative 1 minus negative 5, so it'd be negative 1 plus 5, which makes 4. Negative 5 minus 3, so negative 8. 3 minus negative 1, which is 4. Negative 1 minus negative 41, which makes 40. So we look at our second differences, and since they are not the same, that means it is not quadratic. So we move on to the third differences. And we do 40 minus 4, which is 36. And then 4 minus negative 8, which is 12. Negative 8 minus 4, negative 12. 4 minus 40, negative 36. And we look at our third differences, and they are not the same, so we go on to our fourth differences. So we do 36 minus 12, which is 24. 12 minus negative 12, which is 24. Negative 12 minus negative 36, which is 24. So since our fourth differences are constant, that tells us that the function is quartic. And that means it is degree 4.